Morning everyone, my name is Harshit. I am from civil engineering first year. Today discuss about Newton's law of cooling. Introduction to Newton's law of cooling. Newton's law of cooling describes how the temperature of an object changes over time as it approaches the ambient temperature. It is based on the idea that the rate of heat loss in potential to the difference in temperature between the object and its surroundings. This law helps us understand and predict cooling and breathing, heating processing in various scientific, scientific, scientific and engineering applications. Historical background. Sir Ellis Newton formulated the law in the 17th century as part of these studies on heat transfer. The law has been refined through experimental validation and mathematical modeling over the centuries. It remains a fundamental princi- principle in thermodynamics and heat transfer analysis. Mathematical expression. The law is ex- expre- expressed mathematical as mathematical expression equation. That T is the temperature of the object, T is the ambient temperature, and K is a positive constant related to the cooling rate. The negative sign indicates that the temperature difference decreases over time. Derivation of the equation. The differential equation is derived based on the assumption that the heat transfer rate is potential to the temperature decreases. By integrating the differential equation, we obtain the exponential decay function describing temperature change over time. The solution provides a practical way to calculate the temperature of an object at any given time. Solution to the differential equation. The general solution is this is the differential equation where T is the initial temperature. This equation shows that the temperature approaches the ambient temperature synthetically as time progresses. The constant K influence how quickly the temperature approaches the ambient temperature. Applications of Newton's law of cooling. It is used in forensic sciences to estimate the time of depth based on body cooling. Engineers use it to model cooling of electronics components and machinery. It also helps in designing thermal systems and insulation for buildings. Factors affecting cooling rate. The material properties of the object, such as surface area and thermal conductivity, influence the cooling rate. Environmental conditions like air flow, humidity, and temperature also impact the cooling process. The experimentation assumes a uniform temperature distribution within the object, which any many not may not alone be accurate. Limitations of the law. Newton's law assumes a constant ambient temperature, which is not always the case in real scenarios. It is most accurate from small temperature difference and simple thermometers. The law does not account for phase changes or another complex heat transfer mission ma- ma- magnesiums. Experimental wealthy nation. Numerous Numerous experiments has confirmed that exponential nature of cooling described by the law. Data fitting techniques are used to determine the cooling constant K for specific objects, objects and conditions. These experiments help improve the accuracy of models based on Newton's law of cooling. Conclusion: Newton's law of provides a simple yet powerful model for understanding temperature change over time. Its applications span many fields, includes engineering, mechanics, and forensics. Despite its limitations, it remains a fundamental concept in the study of heat transfer progresses.